What is the difference between stochastic and deterministic policies in RL? Imagine you're playing a game where your choices shape what happens next. Now, think about how an artificial agent makes decisions in a similar way. That's where policies come into play. In reinforcement learning, a policy is like a rulebook that guides the agent on what action to take based on the current situation. But not all policies are the same. Some are predictable, always choosing the same move in a given situation, while others introduce a bit of randomness. This difference is what separates deterministic policies from stochastic ones. A deterministic policy is straightforward. It always picks the same action when faced with the same state. For example, if a robot is navigating a maze and reaches a specific junction, it might always turn left. This makes the robot's behavior predictable and easy to understand. These policies are often used in environments where things stay steady, like factory automation or simple game AI. They are simple to implement because they follow a clear rule: for each situation, do this. But they can be less flexible in unpredictable or changing environments. On the other hand, stochastic policies add a layer of randomness. Instead of always choosing the same move, they assign probabilities to each possible action. So at a particular junction, the agent might turn left 70% of the time and right 30%. This randomness helps the agent explore different options, which is especially useful when the environment is uncertain or changing. It allows the agent to try new strategies and avoid getting stuck in a bad routine. These policies are common in algorithms that need to balance exploring new actions and exploiting known good ones, like policy gradient methods or actor-critic models. Deciding which policy type to use depends on what you're trying to achieve. If your environment is stable and predictable, a deterministic policy can be more efficient and reliable. But if there's a lot of uncertainty or the environment changes often, a stochastic policy offers more flexibility. It helps the agent adapt and find better long-term solutions by exploring different possibilities. In the world of artificial intelligence and machine learning, understanding these differences is key. When training reinforcement learning agents, like those used in game playing or robotics, choosing the right policy type can make a big difference. For example, during training, stochastic policies help explore many options, leading to better learning. Once trained, a deterministic policy might be used for consistent, predictable performance. From an ethical perspective, stochastic policies can introduce variability that might affect fairness or reliability. Developers need to consider how randomness impacts decision-making, especially in sensitive applications. Many AI tools and plugins that use reinforcement learning benefit from selecting the appropriate policy type to match their goals, whether it's exploring new strategies or providing consistent results. So, whether you want your agent to stick to a plan or to try different approaches, knowing the difference between stochastic and deterministic policies helps you shape smarter, more adaptable artificial systems.